Adding a floodlight to your washing machine circuit is generally permissible as long as you adhere to electrical safety guidelines. The primary consideration is the total amperage draw on the circuit. Each circuit is designed to handle a specific maximum amperage. Exceeding this limit can lead to overheating, trip breakers, or even electrical fires. Before making any modifications, it's crucial to determine the current amperage load on the washing machine circuit and the anticipated amperage draw of the floodlight. Washing machines typically draw a significant amount of power, especially during startup and operation. Check the washing machine's nameplate for its amperage rating. The floodlight's packaging or housing should indicate its wattage. To convert wattage to amperage, use the formula amps equals watts divided by volts. In a standard 120-volt circuit, a 100-watt floodlight would draw approximately 0.83 amps. Once you have determined the amperage draw of both the washing machine and the floodlight, add them together. Ensure the total amperage does not exceed the circuit breaker's rating. If the circuit breaker is rated for 15 amps, the total load should not exceed 12 amps, which is 80% of the breaker's rating, according to the NEC. If the circuit breaker is rated for 20 amps, the total load should not exceed 16 amps, also at 80% of the breaker's rating. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations. While skimming through the NEC might provide some general information, it's essential to consult the relevant sections for specific requirements and safety standards. The wire gauge used in the circuit is another critical factor. A 12/2 wire, commonly used for 20 amp circuits, can safely handle a higher amperage load than a 14/2 wire, which is typically used for 15 amp circuits. However, the circuit breaker's rating must match the wire gauge. Using a 20 amp breaker on a 14/2 wire is a safety hazard. While a dedicated circuit for a washing machine is common, it doesn't inherently prohibit adding other loads as long as the total amperage remains within safe limits. It is good practice to ensure all electrical connections are secure and properly insulated. Loose connections can cause arcing and overheating, posing a fire risk. When working with electrical wiring, always turn off the power to the circuit at the breaker box. Use a non-contact voltage tester to verify that the power is off before touching any wires. If you are unfamiliar with electrical work or unsure about any aspect of the project, it's always best to consult with a qualified electrician. They can assess your specific situation, ensure the work is done safely and according to code, and provide valuable peace of mind. Remember that electrical codes and regulations can vary depending on your location. Local codes may have additional requirements or restrictions beyond the NEC. Check with your local building department or a qualified electrician to ensure compliance with all applicable codes. The NEC addresses various aspects of electrical installations, including circuit sizing, wiring methods, grounding, and overcurrent protection. Understanding these concepts is crucial for ensuring electrical safety. For example, the NEC specifies the minimum size of conductors for different amperage ratings and the proper methods for grounding electrical systems. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect circuits from overloads and short circuits. When the current exceeds the breaker's rating, it trips, interrupting the flow of electricity and preventing damage to the wiring and equipment. The NEC also addresses the installation of outdoor lighting fixtures, including floodlights. It specifies requirements for weatherproofing, grounding, and mounting to ensure safety and prevent water from entering the electrical system. When installing a floodlight outdoors, use weatherproof electrical boxes and fittings to protect the connections from moisture. Ensure the floodlight is properly grounded to prevent electrical shock. If the floodlight is mounted on a metal surface, the surface must also be grounded. The NEC also covers the use of ground fault circuit interrupters, or GFCIs, in wet locations such as bathrooms, kitchens, and outdoor areas. GFCIs are designed to detect small imbalances in the current flowing through a circuit and quickly interrupt the power, preventing electrical shock. Consider installing a GFCI outlet or breaker to protect the washing machine circuit and the floodlight, especially if the floodlight is located in a damp or wet area. When working with electrical wiring, use the proper tools and equipment. Wear insulated gloves and safety glasses to protect yourself from electrical shock and eye injuries. Use a wire stripper to remove insulation from wires without damaging the conductors. Use a screwdriver with an insulated handle to tighten screws on electrical connections. Never work on live electrical circuits. Always turn off the power at the breaker box before starting any electrical work. Verify that the power is off using a non-contact voltage tester. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Electricity can be dangerous, and it's important to take all necessary precautions to ensure safety. In summary, adding a floodlight to a washing machine circuit is generally acceptable as long as you follow electrical safety guidelines, ensure the total amperage draw remains within safe limits, and consult with a qualified electrician if you have any questions or concerns. Always prioritize safety when working with electricity. The NEC is a valuable resource for electrical safety information, but it's essential to consult the relevant sections for specific requirements and regulations. Local codes may also have additional requirements that you must follow. By taking these precautions, you can safely add a floodlight to your washing machine circuit and enjoy the added lighting without compromising electrical safety. When considering the addition of any electrical load to an existing circuit, a thorough assessment of the circuit's capacity and the existing load is crucial. This assessment should not only consider the nameplate ratings of appliances but also factor in potential surge currents, which can be significantly higher than the continuous operating current. For instance, motors, such as those found in washing machines, can draw a much larger current during startup than during normal operation. This surge current can briefly exceed the circuit breaker's rating, potentially causing it to trip. Therefore, it is advisable to use a clamp meter to measure the actual current draw of the washing machine during its various operating cycles, including startup, washing, and spinning. This will provide a more accurate picture of the circuit's existing load. Similarly, the floodlight's wattage should be carefully considered, and its actual current draw should be verified using a multimeter. While the formula amps equals watts divided by volts provides a good estimate, the actual current draw may vary depending on the type of bulb used and the efficiency of the fixture. Furthermore, it is important to consider the type of circuit breaker used in the panel. Standard thermal magnetic circuit breakers are designed to trip relatively quickly in response to overcurrents. However, they may also trip due to nuisance tripping caused by inrush currents from appliances or lighting fixtures. In such cases, a time delay circuit breaker, also known as a slow blow circuit breaker, may be a better option. These breakers are designed to tolerate brief overloads without tripping, making them suitable for circuits that power motors or other devices with high inrush currents. However, it is crucial to ensure that the time delay breaker is properly sized to protect the wiring and equipment on the circuit. The NEC provides specific guidelines for selecting and installing circuit breakers. The NEC also addresses the issue of voltage drop in electrical circuits. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause appliances and lighting fixtures to operate inefficiently or even fail prematurely. The NEC specifies the maximum allowable voltage drop for branch circuits and feeders. To minimize voltage drop, use conductors of adequate size and keep the circuit length as short as possible. In some cases, it may be necessary to increase the conductor size to compensate for voltage drop. The NEC provides tables and formulas for calculating voltage drop. When adding a floodlight to an existing circuit, it is also important to consider the location and environment in which the floodlight will be installed. If the floodlight will be exposed to the elements, it must be rated for outdoor use and properly weatherproofed. The NEC specifies requirements for outdoor electrical installations, including the use of weatherproof enclosures, fittings, and wiring methods. It is also important to ensure that the floodlight is properly grounded to prevent electrical shock. If the floodlight is mounted on a metal surface, the surface must also be grounded. If the floodlight will be installed in a damp or wet location, a GFCI should be used to protect the circuit. GFCIs are designed to detect small imbalances in the current flowing through a circuit and quickly interrupt the power, preventing electrical shock. The NEC requires the use of GFCIs in certain locations such as bathrooms, kitchens, and outdoor areas. When making any electrical modifications, it is essential to follow all applicable codes and regulations. The NEC is the most widely adopted electrical code in the United States, but local codes may also have additional requirements. It is important to check with your local building department to ensure that your electrical work complies with all applicable codes. In addition to complying with codes and regulations, it is also important to use high-quality materials and workmanship. Electrical work should be performed by a qualified electrician who is familiar with the NEC and local codes. Using substandard materials or improper wiring methods can create safety hazards and lead to future problems. It is also important to inspect your electrical system regularly to identify any potential problems. Look for loose connections, damaged wiring, or other signs of wear and tear. If you notice any problems, have them repaired by a qualified electrician as soon as possible. Electrical safety is paramount. Always turn off the power at the breaker box before working on any electrical circuits. Use a non-contact voltage tester to verify that the power is off before touching any wires. Wear insulated gloves and safety glasses to protect yourself from electrical shock and eye injuries. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. By following these guidelines, you can safely add a floodlight to your washing machine circuit and enjoy the added lighting without compromising electrical safety. Firstly, it is important to reiterate that a dedicated circuit doesn't inherently prohibit adding loads within the established electrical safety parameters, mainly total amperage draw. Secondly, consider using a clamp meter to measure the appliance's actual amperage during various operational stages. Thirdly, the selection of the correct circuit breaker is crucial, possibly considering a time delay type for motor-driven appliances. Fourthly, always address potential voltage drop by using appropriately sized conductors. Fifthly, ensure that the floodlight is rated and installed correctly for the environment, particularly for outdoor use, ensuring weatherproofing and grounding. Sixthly, GFCIs are critical in damp or wet locations to safeguard against electrical shock. Seventhly, adhere strictly to all applicable codes and regulations, including local amendments to the NEC. Eighthly, insist on high-quality materials and professional workmanship for all electrical modifications. Ninthly, regularly inspect electrical systems for wear and tear, addressing any issues promptly. And finally, prioritize electrical safety by energizing circuits before working on them and using appropriate protective gear. If uncertainty persists, consult a licensed electrician.